Good day. I am here to present the study on the factors affecting land use and land cover change and fragmentation in selected protected areas in the Philippines. Protected areas are affected by the land use changes caused by human activities, and this alters the ecosystem functions and PA sustainability. The consequences, such as fragmentation, leads to habitat loss. In the Philippines, deforestation and forest degradation are the most pressing concern. Our PAs struggle in habitat loss within its boundaries. With the legislation of the expanded National Integrated Protected Areas System Act of 2018, the increased number of PAs, which is a strategic action to halt biodiversity loss and minimize the destruction of resources. The general objective of this study is to provide an assessment to the factors which affects forest cover change and fragmentation of land cover types in selected protected areas. Specifically, it aims to characterize the PA landscape by analyzing the LULC change and fragmentation, identify its factors, study the relationships between the driving factors, as well as provide prospective implications of such relationships and be able to recommend strategic actions to further improve PA management implementation. The 33 terrestrial PAs were selected based on the existing Management Effectiveness Tracking Tool, or MET score, on the seminal report of the Biodiversity Management Bureau. The GIS-based data on land cover and road networks were collected from NANRIA, while the PA boundaries were publicly available at the World Database of PA website. The ArcGIS and the FragStats software were used to obtain the LULC change and values on fragmentation metrics. The canonical correspondence analysis was employed to see the relationship of all dependent and independent variables. And then a stepwise regression analysis was used in identifying which particular factor drive these changes, and from that, we were able to provide conclusions and recommendations towards the improvement of PA management. This graph shows the increase and decrease of forest cover in two periods. The gray line shows the overall change of forest cover in 33 PAs, in which it is found that it's still experiencing decline despite the fact that it is within the protected landscape. The results of the correlation matrix shows that the relationship between the dependent variables and the driving factors has a very weak to moderate relationship. The highest correlation of 0.572 implies a moderate positive relationship between the number of patches and population. And the next notable coefficients are negative 0.438 and negative 0.427, which imply that the negative weak relationship between cultivated areas to closed forest. The driving factors show distinctive relationship and strength of association with the corresponding dependent variables. This table shows that the only significant variate is variate 1. Its p-value less than 0.05 means that we reject the null hypothesis that there is no relationship between the two sets of variables. The canonical correlation value at 0.96 implies a strong positive relationship. Despite the high canonical correlation, the redundancy index, which measures the magnitude of the relationship, implies that 12.7% of forest cover and fragmentation can be explained by the driving factors. The canonical weights was investigated to identify the most important predictor among the driving factors. The weights greater than the absolute value of 0.30 can be taken as an important contributor to the function. The results indicates that cultivation within the PA is the most important predictor on cover change and fragmentation. The other two noteworthy variables are HDI and the regional GDP. Studies only consider the predictor that have the canonical weight greater than the absolute value of 0.30. But in this study, all the variables were first considered and taken into stepwise procedure to obtain the best fit model. For factors affecting closed forests, the result shows that the regional GDP and the presence of cultivated area inside the PA have a negative impact on the forest. The agricultural expansion has a major role and a key contributing factor to deforestation. Furthermore, the probable cause of forest depletion is the economic goal of GDP increase. Logging for production contributes to the value increase of GDP rather than sustaining forests for ecosystem benefits. This result supported the study of Errors and Quaresma in 2006 and 2017 respectively. Low-income countries tend to have lower forest cover as GDP increases. As for the open forest, results shows that as MET score improves, OF tends to decrease. This may be this may imply the development of the open forest to a closed forest as the management progressed. The PAs may have been experiencing reduction threats that has further facilitated the increase of canopy cover. However, MET indicators may have also improved, but it may not directly benefit the protection and the conservation of the forest. This points to the need to examine the management and effective policy implementation. The result shows that NP tends to increase as population escalates. The upward trend in NP causes severe impacts on forest structure and ecosystem dynamics of old-growth forests that results to disruption of biodiversity. Hence, the encroachment in PAs are not well confined by the isolation of the forest through PA establishment. Meanwhile, heightened poverty is due to yield decline caused by unproductive agricultural lands. Thus, the small-scale farmers were more likely to clear forests to expand farming into a more productive soil found in forested areas. Consequently, reducing the patchiness of the PA landscape has an effect of aggregating cultivated areas and diminishing forest cover. The results on path rock may be observed in PAs with presence of high cultivation, which causes other land cover types to be more irregular in shape as cultivated area expands. The changes in path rock are influenced by the anthropological activities, and in this study, it seems that the presence of road in PAs have a regulatory effect as it lessens the form of complexity of land cover patches. Therefore, the road becomes a tool for regulation where park managers can access the remote areas and the confinement of the intense human activities in the PA are effectively enforced. The results found in contact implies destruction of habitat and poses a serious threat to biodiversity, hence impedes with the achievement of the goal of PA establishment due to agricultural expansion. These add more challenge as regulation fails, that the non-forest patches tends to multiply and expand over time. This will eventually result to reduced, scattered, and highly separated forest habitats across PE landscape. The higher the mean E and N, the more isolated the patches are. This can be explained by the behavior of people with increasing poverty. Human activities tend to increase in remote areas of forest frontiers for subsistence, consequently accelerating fragmentation by the development of other land cover types. Thus, separation increases to those of the similar land cover types. For instance, a forest patch to another forest patch. This is yet again another likely effect of poverty on protected areas. The poor would tend to extract natural resources through unsustainable harvesting and do extensive farming for livelihood. Furthermore, the population as the population increases, the spread between each patch type widens. The increasing population growth surrounding the PAs may eventually lead to migration of the poor to the uplands and forested areas. This population growth has an effect on land use pattern for agriculture, forest cover, and other types in which the change in distances among land cover types is one of the possible manifestations. Other than the intensified human activity in the PA, one of the possible explanations of the increase in land cover patch diversity is the presence of the Special Use Agreement for PA. Another implication of this result reveals that the problem in the scoring process of the MET. Other than the issue on the MET scoring or questionnaire being subjective, the results to people's perception alone creates a bias on the overall result, since the people who answer the questionnaires are those involved or part of the management. Hence, the score tends to be higher. There are no significant variables found for LPI, AI, and SIBI. This is possibly due to data and sample size limitations. Here are the key findings of this study. Looking at all the significant regression models, cultivation is the most notable driving factor. Therefore, the regulation of human activities, particularly the expansion of the cultivated area and the exploitation of natural resources, must be given strong attention by PA managers. It is assumed that the higher the net score, the more provisions of PA policy are implemented accordingly. At 95% confidence level, we have the data to say that the performance of the PA management reflected by the MET scores affect the land use and land cover in terms of open forest and the diversity index. The higher the MET score implies lower open forest. This could be explained by the reduced threat or hindrance towards forest canopy growth. However, the increased net score could also mean the improvement of other indicators that indirectly affect the forest canopy growth, leading to its decline amidst the higher score in certain PAs. On the other hand, there are more variations of land cover types present in the PA. The findings also show that the PA management, which is being reflected in net score, only have a minimal impact to forest conservation. Thus, the PA management plan needs to be developed and implemented appropriately. Strict enforcement of rules and regulation, control of human disturbances, and elimination of the agricultural encroachment are the necessary actions to be done. This study recommends to reevaluate the MET score to give better measure of the positive impacts of good management of PA, and the following may be included for consideration: giving greater weights to the regulation of the drivers of forest cover change external to the PA, such as cultivation in the periphery of the PA, and likewise giving more weights to the management and regulation of the construction and maintenance of road systems in and around the PA may be considered in evaluation of PA management effectiveness. Identify programs or policies being implemented to protect the site and rate the effectiveness. Compare the patches from previous data and the present percentage area used. We could also complement the subjective performance evaluation with the use of more objective quantitative evaluation, such as GIS-aided land fragmentation analysis for the assessment of the overall condition of land cover quality, specifically the forest cover. Improve other policies, not just the net application, to quantify the improvement of land cover at different times and seasons. In order to enhance the accuracy of the next study, it is recommended to use the up-to-date data for all variables. It is also recommended to have more PA management operations in confining and regulating the human activities, particularly the expansion of cultivated area. Provision of sustainable resources of livelihoods and suitable settlement areas would also be considered to help minimize the incursion of communities into the PAs. Moreover, the best fit models range from 15% to 48%, for which clearly indicates more key factors that were not included in this study due to data limitations. It is also recommended to test other variables such as LGU activities, livelihood of stakeholders, and include demographic variables such as the quality of life among stakeholders and their sources of income. Obtaining data for gross domestic product down to the municipal or provincial level would further bring clarity to the study. More fragmentation metrics such as edge effect, shape index, edge contrast index, and run the analysis down to patch level may also be considered in future studies. Furthermore, the study suggests a more holistic ridge-to-rate approach in the analysis of the PA management effectiveness and look at the PA in a broader context, taking into consideration the interconnectivity of the PA condition with the physical and the anthropogenic activities that are taking place in other parts of the landscape units where PA is located. Here are some of the references used for this study. I would like to thank the Philippine Council for Agriculture, Aquatic, and Natural Resources Research and Development and the Science Education Institute of the Department of Science and Technology for fully funding this research. This is through the Graduate Research Education Assistantship for Technology program. And I would also like to extend my gratitude to Dr. Predo and Ms. Bakmay for the statistical advice in this study. Thank you for listening.